Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon. Okay, so what we have discussed in the previous lecture.
Ma'am, example of Rabin crypto system.
Okay, Rabin crypto system example is done, right?
Yes.
And I have given you one more example also. P equal to 11, I think, and Q equal to 3, something like that. Let me just check. Yeah, P equal to 7 and Q equal to 11. And the message M equal to 20, I think I have given to you people. Yes? Yes or no? Huh? Yes, yes. But have you solved this example? Okay. Already we have discussed the procedure of Rabin crypto system, so you need to solve that example if you have not yet solved it. Okay. Next, moving to the next algorithm, that is algorithmic cryptography. So I will be writing the procedure over here. Either you can take a screenshot or you can also write it down. Anyhow, we have to calculate the example. So better you keep record of writing. Algorithmic cryptography. Okay. Again, it is a asymmetric crypto system. Sorry. Asymmetric crypto system, right? So here, see, any algorithm, there are total 3 steps we can say which are involved. First of all, we need to check how the key is generated. So key generation. The second part of the algorithm focus on the encryption, right? And obviously the last part, decryption. Agree with this? We have seen RSA and Rabin crypto system, right? So we used to first select the keys, that is key generation. We used to calculate the keys either based on the algorithm, based on the equations, right? Then we used to do the encryption. So for that we must have what? The message and public key, right? And then we used to have the decryption. So in algorithmic cryptography also we are having the 3 steps, that is key generation, encryption and decryption. Okay, so very simple procedure. I'll be writing the steps and will explain you with the example. Okay, so the very first thing that you need to do is select the large prime number P. Prime number P. Okay, second step is you also need to select the decryption key. Select, I'm writing in short, decryption key, that is D. Okay, private key you can say. Okay, third, you need to select the first part of encryption key. I'm writing in short EK, that is encryption key, or public key. Okay, which I am, see, first part I have written over here. So I will be using the pairs. E1 is a key, encryption key, that is the first part of the key. Okay, so I will be, sorry, the fourth step, I will be having E1 and E2 in this case. Okay, so it's a part of the key. Then I need to select the second part of the encryption key. Select, not select, but we need to calculate, okay? Second part of encryption key, which I am giving name as E2. Now, as I have assumed 3 things, that is P, D and E1, now I will be able to calculate E2 as the equation of E2 is E2 equal to E1 raised to D mod P. Okay. And finally, I will be having the public key. See, private key I already have selected, right? And public key anyhow I am calculating. Okay, with these three parameters E1, D and P. Okay. So here I will be having the public key, which I am going to denote like this: E1, E2 and P. So this is your public key, final public key. Okay, as I told you that this is only a part of the key, right? The second part of the key is like this, and finally public key is going to be denoted like this in algorithmic crypto system. Okay, that is E1, E2 and P. Okay, any doubt in this? First three steps you just need to select the numbers, and fourth and fifth we just need to calculate the thing. E2 we need to calculate, right? And this public key I am going to announce to the channel.
नहीं तो पब्लिक की है
Yeah, public key. So public key you can, yes.
प्राइवेट की क्या है
Private key, here it is private key, decryption key D. This is all example. Okay, we need to assume three things. See, prime number P, the decryption key D, and the public key, a part of the public key E1. These three things you need to select. Okay. Now moving ahead towards the example, and then I will show you the encryption decryption also. So very first thing, let P equal to prime number, right? So I am taking it as 11. Second, I am assuming decryption key D equal to 3. You can take any. Third, I am assuming E1 equal to 2. Again, you can take any, right? Fourth, I need to calculate E2, and the equation is E1 raised to D mod P. So as I have all of these values now, can just put the values and let me know the value of E2. And I will be having the public key E1, E2, P, which I am going to calculate. What is E1? 2, comma, whatever E2 is there.
8
Okay, E2 is 8, right? That is,
8
E1 is what? 2. 2 raised to D, that is 3. Mod 11. So 8 mod 11 is what? 8. So 8. And P is what? 11. So this is your public key. Clear, everyone?
yes ma'am
Okay. Now next, you need to do what? Encryption. So for encryption, the very first thing you should have what? Public key. Okay. So public key is with you, yes. And you should have the message also, right? To which you are going to apply the public key for encryption. So public key plus that is going to be applied on message, and then we will be having the encrypted message, or we can say ciphertext, right? So we will do the encryption now. Okay. So let plain text equal to 23. This also you need to assume. Encryption. Okay. So the steps are, very first thing, you need to select the random number R. Select random number R. Okay. So here I am selecting R equal to 4. Second, now you will be having the ciphertext also in two parts. So C1, C2 you will be getting. So equation of C1 is E1 raised to R mod P. So do I have the values of all the things E1, R and P? The R I just assume, E1 and P we already have assumed, right, during the key generation. So just put down the values and let me know the value of C1. What is E1?
Even two.
Even 2. What is R? We just assume it is 4.
Four.
What?
Four.
And what is P?
Mod 11. 11. 11.
Mod 11.
5 will be answer.
5.
5 will be the answer, right? So C1 equal to
Five. Yes.
5. Yes. Now C2. C2 is plain text into E2 raised to R, and it is mod P operation, modulo P operation. Okay. So see, so in this case, you just need to remember the equations. Okay. Otherwise, the procedure is very, very easy. C2, the equation is given plain text into E2 raised to R mod P. So again, we do have all the values. We just need to put the values. 23 is my plain text. What is the value of E2? 8. We already have, right? 8 raised to 4, R we assume, and mod 11. So compute this and let me know the answer of C2 also. Plain text, you can just take 7. 7. You can take 23 also, not an issue. But here, for this example, we have taken 7.
Six. C2 6.
Okay, so C2 is 6, right? Now I do have the cipher text as C1 C2, that is equal to 5 comma 6, right? Next we need to do the decryption. Encryption we have done. Okay. So the equation, I will be writing the equation, you just need to solve it out, okay? Plain text equal to C2 into C1 raised to D inverse modulo D. We do have each and every value, you just need to solve and let me know the value of PT. I hope everyone is aware with the multiplicative inverse concept. Okay, we already have done the examples. So finally you should get the answer of the plain text as 7, as we have encrypted what? 7, right? And unlike grabbing, this is not non-deterministic algorithm.
हेलो मैम,
Yes.
ऊपर करो स्क्रॉल.
Huh. Here.
यस मैम.
Okay. Chalo, done.
Yes, ma'am. Yes, ma'am.
Okay, so you are getting 7, right?
यस मैम.
Okay. You must get 7, right? Okay. So that's all about this Algama crypto system. Okay. No extra thing we require to understand, right? As we have discussed many concepts while discussing the Webin and RSA crypto system, right? We have learned so many small theorems and some mathematical concepts. Okay. In this, you just need to remember the equations. That's it. Okay. Then moving forward. The next algorithm that we are going to study is ECC, that is Elliptic Curve Crypto System, right? But before studying ECC, we need to discuss two more concepts of mathematics, that is discrete logarithmic problem and primitive roots. You can just check the dependencies, right? If I need to understand ECC, I should be having the knowledge of discrete logarithmic problem, which is known as one-way function concept, one-way function, or trapdoor. We can say trapdoor function. Okay. And if I want to understand this DLP concept, I should know what primitive root concept. Okay. So starting with this first concept, that is primitive roots. Have you heard of this before? Primitive root concept. Yes or no? No. Okay. So let us understand this. What is the aim or goal of this primitive root concept? So it will help us to determine whether a number is primitive root of given prime number or not. Okay, this is a we can say a simple statement. It will help us to determine whether the given number is a primitive root of a prime number or not. Okay, we will see the example so it will be clear with you people. The formal definition says that I can say that alpha is primitive root of some prime number. As I have mentioned over here, we need to check for the prime number only. So prime number p, let us say it's p, okay. If alpha raised to 1 mod p comma alpha raised to 2 mod p comma alpha raised to p minus 1 mod p will give you unique numbers. Okay, what I can say is alpha is a primitive root of the prime number p. Okay, alpha is a primitive root of prime number p if and only if alpha raised to 1 mod p, let's say it is giving you 1, alpha raised to mod p, let's say it is giving you 3, alpha raised to p minus 1. This procedure you need to continue till what? Alpha raised to p minus 1. Okay, so it depends on this p. Okay, let's say p equal to 5. P is a prime number? Yes. 5 is a prime number? Yes. So this procedure I need to continue till alpha raised to 4. So each and every value, that is alpha raised to 1, alpha raised to 2, alpha raised to 3, alpha raised to 4 mod p will give you what? The unique values. No value is repeating. Or also we can say uniformly distributed. Okay, so what I can say, if you are getting this kind of values, then I can say that yes, alpha is a primitive root of what? Prime number p. Clear the definition? Yes or no?
Yes.
Just a second. Okay, just a second. Yes. So I hope the definition is clear to everyone. We will quickly go through the example if the definition is clear. Tell me, clear?
Yes, ma'am, clear. Yeah.
Okay, Bhautik, Meet.
Yes, ma'am.
Okay, Rudra.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, yes.
Okay, so let me take one example. I need to check is 2 a primitive root, I'm writing in short, primitive root of prime number 5 or not. Okay. So what I need to check, 2 raised to 1 mod phi equal to what? 2 raised to 2 mod phi is equal to what? 2 raised to 3 mod phi is equal to what? And 2 raised to 4 mod phi is equal to what? According to definition, alpha raised to 1, alpha raised to 2, up to alpha raised to p minus 1 I need to go. So alpha raised to p minus 1, what is p? 5. So 5 minus 1 is 4. So I need to check these 4 values. If each and every value are unique, then what I can say is 2 is primitive root of 5. Alpha is primitive root of prime number p. Okay, but if any one of the value is repeating, okay, I'm not getting the uniformly distributed values, then I can say 2 is not a primitive root of prime number 5. Okay, so quickly find these values and let me know whether they are unique or not.
Yeah.
They are unique.
They are unique. Yes, ma'am.
Yes, ma'am. 2, 4,
This you will
5,
get
and
2.
1.
Okay, this you will get 4, this you will get 3, and this you will get 1, right? So yes, all the values are different. So I can say yes, 2 is a primitive root of 5. Okay, so I will give you 2 3 more examples. You need to just quickly solve it out and let me know the answers. Okay, I'll be writing the values of alpha and prime number p. Alpha is equal to 3, prime number equal to 5. Alpha is equal to 2 and prime number is equal to 7. Alpha is equal to 2 and prime number is equal to 11. Okay, these are the 3 questions that you need to solve right now. Done?
Yes, ma'am.
Okay, so tell me for the first,
Yes.
is a primitive root or not?
Yes. It is
Ye-
primitive
Yes,
root.
ma'am.
Done. First one is primitive.
Okay, the
Second
second
one is
one.
not.
Is not primitive.
Okay, and the third one.
Is primitive.
Okay. Okay, so you know now, or you are aware about this concept now, right? What is primitive root of a prime number? So let us go through the next concept, that is discrete logarithmic problem. Have you heard about this one-way function? DLP, that is discrete logarithmic problem. Okay. Have you heard about this term, one-way function? What do you mean by one-way? Have you heard this term first time?
Yes, ma'am.
Forget about function. What is one-way?
One directional.
One direction only, right? So can you just justify what is the strength of this one-way? Or is there any, do you find any strength in this one-way function? What will happen if we apply one-way in our crypto system?
Cannot be reversed.
Encryption થશે પણ decryption ના થાય એવું
No,
કહેશો.
no, no, nothing, no, not like that. Yes, the previous answer,
It cannot be reversed.
the procedure cannot be reversed, right? So that's the strength of the one-way function. Okay, I will give you one analogy and then you will be easily understand what is one-way function, right? So let's say that I want to make tea, right? So which ingredients are required? Bolo?
Sugar, tea, leaves,
Tea
milk.
leaves, milk and water, right? This is tea leaves. Okay. So if I'm having these four ingredients, I will be easily making some tea, right? Okay. Now I do have tea and you need to tell me the exact amount of each of the ingredient. How much sugar, how much tea leaves, how much amount of water and how much amount of milk was used. You have this. So can you tell me the exact amount of these four ingredients?
No, ma'am.
No. So that's the strength of the one-way function. Okay. If you have been asked to make the tea from these four ingredients, it will be very easy for you. But the reverse procedure is difficult, right? So that's the strength of, we can say, one-way function. Okay. So we need to understand now the discrete logarithmic problem, and as I told you, if you want to learn about this, you should be knowing about the primitive roots concept, and we already know this. Okay, so first we will take the example, we will understand through the example, and then I will give you the theoretical aspects of this DLP. Okay, because understanding example is more important. Okay, so you need to tell me pi is a primitive root of 17 or not. This is your alpha and this is your prime number p. So you calculate this, okay, and let me know whether alpha is a primitive root of 17 or not. Done?
Yes, ma'am.
Yes. So tell me whether alpha is a primitive root of 17 or not.
It is.
It is. Yes. So see, we do have this 5 raised to 1 mod 17 to 5 raised to 16 mod 17, right? Because we need to go to up to p minus 1. Okay. So you are getting the uniformly distributed values for this, right? You are having the unique values or uniformly distributed values. The reason is it is applicable if and only if this prime number, sorry, this alpha is a primitive root of prime number. Then and then you will be getting this value, okay, unique values or vice versa. Okay, now let's say, now this phi is known as, this is known as a generator, or we can say the primitive root of your prime number which is given to you. Okay. Now let me write one equation. If I am writing phi raised to x, x can be any number, and I have written this mode 17. Is the computation is easy for this equation? X can be any number. Computation is easy or not? Getting my question? See, why we are getting these uniformly distributed values? Because this is a primitive root of 17. Or you will get the uniformly distributed values if and only if this is the primitive root of 17. Both are the same things, right? Now tell me, if you have given this equation 5 raised to x mod 17, where x can any number, computation is easy or not? Just remember that T analogy. Are you getting the question?
No, ma'am. Please repeat.
Okay. What I'm saying, see what you have find over here, 5 raised to 1 mod 17. What is the value? 5 raised to 1 mod 17 कितना है?
5.
5. Okay. 5 raised to 2 mod 17?
8.
8. Okay. 5 raised to 3 mod 17?
6.
Huh?
6.
6.
6.
Okay. Now I'm telling that I am having 5 raised to x mod 17, where x can be any number. So will you be able to find this easily? Yes or no?
Any number less than
Not,
17.
no, nothing like that. Nothing like that. It may be 20 also.
Not easily.
Not easily, but you will be able to find a value.
Yes.
Okay.
Yes, ma'am.
Okay. So if I have given 5 raised to x mod 17, x can be any number. For me, x is equal to, let's say, 13. So yes, I will be able to find the value. Okay. Now let me tell you one thing, that if I have given the equation like this, that is 5 raised to x mod 17 equal to 12. Now find the value of x. Now will it be easy for you? Previously I have asked you that find 5 raised to 1 mod 17. So you quickly tell me that it is 5. Then I ask you to find 5 raised to 13 mod 17. Let's say it is 8. So that also you quickly find out. But now what I am telling is, I am having this x as x only, 5 raised to x mod 17, and giving you it is equal to 12. Now tell me what is the value of x. What is the value of x? Or let me just reframe my questions. What are the possible values of x? I hope this question will give you the hint. Tell me, x की वैल्यू क्या होनी चाहिए?
8.
10 के मल्टीपल प्रिमिटिव रूट्स फाइंड कर रहे हैं.
No, I'm not asking you to find out the primitive roots. What I'm telling is 5 raised to x mod 17 equal to 12. Already the value is given to you. Okay, x plus x is given to you on the left hand side, x plus some equation is there, and then 10 is given to you, and I'm asking you to find the value of x. Okay, this is the situation, but in modular operation it is like this: 5 raised to x mod 17 equal to 12 is given to you. So will you be getting the single value of x, or there will be the multiple possible values of x?
Multiple possible values.
Multiple possible values, right? So 5 raised to 9 mod 17, if you will do, you will get 12. If you compute this 5 raised to 25 mod 17, then also it will give you 12. If you do 5 raised to 41 mod 17, then also it will give you 12. Okay, same for 57, 73. I don't know how many possible values are there. So this is the strength of the one-way function. Okay, if this is given to you 5 raised to x mod 17, or let me say I will take x equal to 25, even though this is a large exponential, right? But you will be able to find the single value for this 5 raised to 25 mod 17. उसका एक ही value आपको मिलने वाला है. Yes or no? Yes or no?
Yes.
Yes, ma'am.
Okay, but the reverse is, if I have taken 5 raised to x mod 17 and I am giving you some value that it is 12, on the left right hand side it is 12 which is given to you, so you will be having the multiple possible values of x, right? So this is a one way function, we can say trapdoor function. Okay, so trapdoor means what? See, 12 is given to you and then I am asking you to find the value of x, so then attacker need to try many values. Yes or no? अगर उसको यही बोल दिया होता कि
Yes.
5 raised to 25 mod 17 कर, तो वो इजीली करने वाला था, right? There will be a single possible value, but if this kind of situation is given, then he or she will be having the multiple values, right? Now you can compare these with tea analogy. If you are ingredients and if you have been asked to make a tea, it is very easy for you, but then you have given a tea and then I'm asking you that what is the exact amount of ingredients, then it is difficult for you people. Okay, so let put this in this way, that is x is given to you and I'm telling you to go to the function fx, so it is easy for you, but the reverse procedure is difficult. Okay, until and unless some hint is given to you or some trapdoor value t is given to you, it is not possible for you people to find the value of x from given fx. Okay, and that is known as trapdoor or one way function. Clear the idea?
Yes, ma'am.
Okay, so now I will be telling you the physical aspects of this. Again, very simple, because now you already have learned about the algorithm, the example. G raised to g raised to x mod t. Okay, if I put this in this way, 2 raised to x mod 7 equal to 4, which is already given to you, then for x you will be having the multiple possible values. Two of them are, let's say, 2 and 5. If you put 2, then also you will be getting 4. If you are having 2 raised to 5 mod 7, that is 32 mod 7, then also you will be finding 4. Okay, now this is easy if the prime number p, to find the value of x is easy. To find the value of x is easy if p is a small number, that is I'm talking about this prime number. Okay, So the strength of the one-way function depends on what? How much time it takes to break. Okay, the strength of one-way function depends on what? How much time it takes to break. Okay, so as I told you, if p is smaller, okay, then you will be able to find x easily. Okay, you will be having the less time. In the less time, you will be able to find it out. Okay, but if p is large, so as you have seen in our each of the algorithm, that it is recommended to select the large number of p. Okay, large prime number. So this is how you can apply the one-way function. Now I'm giving you one more example regarding this, and then we'll be done with this concept. Example is, let's say this is given to you, log to the base 2 9 mod 11. Okay, so what is p over here?
11.
11. Now this equation I can rewrite like this. Rewrite means in general terms I can write like this. Log g base x equal to is congruent to n mod p. Okay. Okay. So here your g is what? Base 2. So I'm writing g equal to 2. And what is this? Your alpha, or we can say x. X equal to 9. Okay. So what I can write, x congruent इसको हम इस तरफ लेके जाते हैं. So right hand side, if I am taking it, g raised to n mod p. Agree with this? Yes or no?
Yes, ma'am. Yes.
Yes.
Okay. So values will be having in the equation. 9 is given to you x, g is given to you, that is 2, 2 raised to n mod 11. So same situation, 9 is given to you, but then you need to tell me the value of n, and you will be having the multiple possible values. Getting?
Yes, ma'am.
Okay, so that is your discrete logarithmic problem, which we will be using in the future in some of the algorithm. Any doubt on this?
No, ma'am. No.
Okay. Let me take your attendance. So in the next lecture, we will be starting with the elliptic curves cryptography. Okay, I have marked your attendance. You may leave the meeting. Thank you for joining.
Thank you, ma'am.
Thank you.
Thank you, ma'am.